Hello friends, welcome to this video, and this video is gonna be about continuation of the socket programming. In this video I am going to implement the wait and the stop and wait protocol in UDP. So let's know about what is stop and wait protocol. Stop and wait ARQ, that is automatic repeat request, can also be referred to as an alternating bit protocol, and it's the method used in telecommunication to send information between two connected devices. It ensures that the information is not lost due to drop packet and the packets are received in a correct order. It's the simplest kind of ARQ method. And a stop and wait ARQ sends one frame at a time. It's a special case of general sliding window protocol with both the transmit and receiving window size equal size. So that's a little bit intro. So the it is between two connected devices. Sender sends the packet or frame at a time, and when the receiver side receives that frame or data packet, then it sends the acknowledgement back to the sender, and then sender again sends the data. So this is this chain is done till the whole data is arrived on the receiver side, or the data transfer is complete. So this is according to the need of the user, how much data it want to transfer. The basic thing is that the data only sends, there's only one packet sent at a time, and only when the when the sender receives an acknowledgement, which means that the data is correctly sent, and if it doesn't receive an acknowledgement within a specific period of time known as the timeout, then it again sends the data to the receiver side. So let's directly jump to our code and make it a program on it. So I'm basically going to create two programs, first a server program, another a client program, and in this a client will send data to the server one at a time, and server receive the data and send back the acknowledgement frame. So as it is in UDP, so first we are going to create a simple UDP program. I have another video on how to make a UDP client server in C, which you can see in my videos, and there's also a link in the description, you can see, just check it out now. And if you haven't watched this video, then don't worry, I'm going to give a little bit explanation about the UDP client server programming, don't worry. So let's first create a server. UDP is just a simple protocol. It has no overhead of just making connection with the client and making connection between the step, ensuring that the two devices are connected. But it has also some drawbacks, like there's no guarantee that the data will be reached at the place or the device correctly. So now let's import our, not import, include all our header files. So these are all our header files. Now let's make the main program. Void main int argc char pointer argv So we are going to receive the port number in the as the command line argument. If argc is not equal to 2, then printf uses style s and the port number. Let's reduce the tab size. Now it's okay. Exit it. Let's get the port number. So convert it from ASCII to integer, that is ADY. ARGB 1. Now let's declare our variables. String, so VDR in server ADDR and new server. Server. Now the char buffer size. Now let's create socket. If I need the family, the protocol, mem set. Now let's fill all the structure with the zeros, not zeros, null values. So here we have inserted our write our port number. It's time for the address. And our address is going to be our local address. You can also take this also as in command argument, or you can take it through scanf as an input, but I just know my machine address, so I do not need to just do this whole stuff. So we have just created a socket, basically a UDP. So socket, it's a connectionless protocol, and in this line we have filled all our structure, that is the server ADDR, with the null values, and then we fill our three important values in this structure, that is SYN family, protocol, and the address. Now let's bind our address with the protocol. Server ADDR. Now size of server ADDR. So we have bind it. Now ADDR size, variable which I have already defined above, size of the new server. So till now it is right. Now in the so the next is gonna be about the receiving and sending the packets, the frames. Now just write a simple line of receive to test whether the server is working correctly or not. Then we are going to make changes in this. It should be new ADDR, new server. Okay, new server. It should not be new server. It does not fit that name. It should be new ADDR on, because new client get connected. I don't know why I just used this variable. And then ADDR size, let's make it small. Now let's print this information which we have received. Buffer. Like this, we just make a client program also. Client is a little bit simple than the server program. We just copy the same thing from here till this line. Both the code contain the same thing till this line. Rest differs. Now we just need to connect directly IP and the port. Now it's okay. So let's send some message to the server like hello UDP server. Should be like this. I just write this first. Now send to. In UDP we do not need to connect our client of server. We just directly send the data. For the size of the buffer 0 in the struct. The server ADDR I think, and the now the size of okay. So now our this program is also completed. So now let's compile these two files and see if our code are correct or not. First terminal is going to be for the server and second is going to be for the client. Let's compile the server first. Server, oh, spelling mistake, output server. So we have an error in the mem set and the exit. I haven't put the termination and the mem set. I am just currently writing programs in Python. That's why I just forgot to use the termination, and that's a big problem when you just use two different programming languages at the same time. So this code doesn't have the client one. Server also saved, client one also saved. Now let's compile the server again. So compiled without any error and warning. That's a huge success. Now it's time for the client. GCC client output client. So this is also complete without any error warning. Now let's start the server. The port number 4488 started. Now let's at the client 4488. So you can see server has received the data. Hello UDP sir. This means that our client and server both are working correctly. Now we just need to add the rest of the code to implement the stop and wait protocol. So now we need to make some changes in our code. Let's first remove these two lines. We do not need them right now. Let's first do the code for the client, because the client is going to send the data to the server. We just need to make some structures and type def struct packet. So this is our first structure, and this structure is called packet, and it contains the data basically. Now it's time for the second, the frame. It's called frame, and it contains int frame kind. This defines the type of the frame, whether it's an acknowledgement frame, is sequence, or FN or other basically. But in this video we are going to use need only two, the ack and the sequence. First the packet, we are going to frame with the sequence number, and next is the sequence number SQ and O. The third is the acknowledgement. And the last is the data. Spelling mistake, always check your spellings. I just make huge spelling mistake while typing code, and it's a general problem with all the programmers. Everyone make mistake. Frame ID 0. Let me see if I have terminated all of them correctly. Yeah. Frame send. Now the frame which you are going to send and the frame which you are going to receive. So if we have two frame, int ack receive. This is going to be a flag whether we have received the acknowledgement or not. By default it's the one means that we have received the acknowledgement. So now let's move to more code. Now it's time for the more complicated code. Let's delete these two lines from our, just extend this. Now it's looking for file 1. So this loop will run continuously throughout if ack receive is equals to 1, then send the data. Then send the data, and to data we need to fill over our entries in the frame. Frame send dot sequence number is equals to frame ID. Frame send dot frame kind equals to 1. So the frames is like this. If it is here the frames, if it is 0, then it is, it's 0, then it is an egg. If it is 1, then it's a sequence. That's enough. We do not need more. So if it's 0, then it's acknowledgement. If it is 1, then it's a sequence. Now time for the third. Frame send dot egg is 0. Now enter the data which you want to send. Scanf percentile L buffer. Now let's copy this data in the structure. Packet dot data. See here, the frame send is the structure, the frame, and inside that we have another structure, that is packet, and inside packet we have that we have a variable called data which holds the data. Now the buffer. So we copy the data which is in the buffer to the frame. Now let's send it to the server. This is the same code again, but just a little bit of change. Send to frame send size of frame, then 0, then struct so get your pointer strong value server addr. Now let's check if I've defined it or not. The server, okay, size of server addr. So more lines of code. Now we have sent the frame. Now we have to wait for the acknowledgement and print a message. Frame sent. Now we have to wait for the acknowledgement. Size of server addr, int f receive size, see from fd frame receive size of frame, close this, 0, struct so addr pointer and server addr and addr size. Remove this extra s. So we have received it in received the frame, the acknowledgement frame. Now we just need to check if it contains correct value or not. Now the number of received bytes should be greater than 0 and frame receive dot sequence number should be equal to 0, and frames and dot acknowledgement should be equal to frame id plus 1. If these conditions are met, then we have received the acknowledgement frame. Ack received, and if ack received, then ack received should be equal to 1, and else if we haven't received ack, then print ack not. Let me just pause this video. So ack not received, and then ack receive like should be 0. Now increment the frame id, close the show fd, and now our client program is complete. So in this we have just client just sends the data, not data, the frame, sends the frame and wait for the acknowledgement. If acknowledgement received, then it sends the next frame, else it does not send the next frame. Here we do not have consider the time, the timeout. That's time for the server. We can just copy these two structure directly from here. We do not need to type them again and again. So now again a huge line of code. Just make this, and now that's right. Now let's write the code here also, and a loop continuation loop, int f. The server is first going to receive the data packet. Oh, I haven't defined the variables above, and without that nothing is possible. Only error and errors are possible. Int frame id equals to 0. All the variables are also same. Frames receive, because first we are going to receive frame send so now let's write this frame receive size receive from, so fd frame receive size of frame 0 struct, so addr pointer to new addr which we have defined above, and addr size. So we have received the data frame. Now let's check the conditions that this should be greater than 0, like in the client program. These are the number of bytes received, and frame recv dot, and little gap should be there, frame receive dot frame kind should be equal to 1, and you remember 1 is the, yes, it should be a sequence packet. And frame recv dot sequence number should be equal to frame id. If these conditions are met, then frame is received. Printf frame received, and that print that data. So we have received the frame and print the data. Now it's time to send the acknowledgement. Frame send dot sequence number should be 0. Set it to 0. Frame send dot frame kind, because it's an acknowledgement, it should be 0. So there should be 1 equal only. And the frame act should be equal to frame recv dot sequence number plus 1. So our frame is ready to be sent, the acknowledgement frame. Send to fd, frame send size of frame 0 struct soak addr and new addr size. We have sent the acknowledgement. Oh, just a little mistake. This should be inside this, because if we have received the frame, then we have to send the acknowledgement frame. Now it's correct. And then print a message here. Egg sent. And else, if we haven't received, if these conditions are not met, then frame not received. Then frame not received. Increment, I don't think we need to increment because we haven't used the frame ID anywhere. Let's just do it then only. And then close the socket. So our program is complete. Now let's compile them for server. And you can see we have lots of error and 2 warning. First, at the line number 53 and 55, it should be expected. Line number 53 and 54, 53 and 55, 53, and again the same mistake, the termination, and the 55. Now what's the problem here? Let's compile it again. So we have reduced the one error. So it should be Oh, that's the mistake, that curly bracket. So we have two warning and just one syntax mistake. Send to, should we send to? I just missed ad. Now let's compile it again. So we have two warning. Implicit declaration of clause. I think I haven't included a header file for the clause. Just include 2 3 more header file. I think include stat to touch. I think that's not included, and let's check if this warning goes. The warning doesn't go, and warning doesn't cause any problem, but just to let's go to the client and see how many errors are there. No error, only that warning only, so that's good. Now let's create this server on port number 4489. Server created. Start with the client 4489. Enter data A. So you can see there's some, the server received the data. Server let's start from this. Client sends the data as A, server receive A, server sends ACK, and the client receives the ACK, said that ACK not received, and this prompted the enter data. Let's enter data again. You can see, I think there's some mistake in the client program. The ACK not received. Let's check the client program. It goes through the code once. If f receive size greater than 0, okay. Frame receive frame receive should be equal to 0, okay, and frame send should be 1, okay, should be equal to 0, okay. Egg 1, egg receive 0. What's the problem? If we are receiving that egg, that's a problem, because I'm not getting the thing. Which part of the code is making us egg not received? We'll just do one thing, just print the value of the egg. Printf percentile d egg value. Frame receive. Okay, I have get the thing which is causing this thing. That says it should be frame recv. Let's compile the client program again. Now let's run this again on another port 80 4480 and 4480, and data A. Now again it is running successfully. So this is a small mistake and we have corrected that. Client sends the data A, server received A, server sends the ACK acknowledgement, and the client receive acknowledgement, and the client prompt the data to be entered. Let's be. Now you can see the client doesn't send data until we receive the ACK. If we receive the ACK, you can see if these conditions are not satisfied, then we have just make the ACK receive like 0, and this slight mistake again here. That's why it's prompting in, you can see in the above, it's just we haven't received the ACK and still it's prompting to us to enter data. This is because of that one small error. Now if we just make that mistake again, should be send and see if our program does that thing again with this or not. Now server is running continuously 4480 sends data as C. So you can see here frame not received, so it and the server hasn't sent us the acknowledgement, and we haven't, and here there's no prompt for the entering data. So you can see now this program is running successfully. Let's change that again, compile the program again. One warning on port number 4480. Now let's enter the data again. So you can frame send, and now what? Let's do one thing. I think there's a problem when we need to restart the program again. 8181. Now let's do. Now you can see running successfully again. B C D E F. So you can see this client is sending data to the server and the server is receiving data successfully. So our program that is implementing stop and wait protocol in UDP is working successfully. So I think that's all for this video. If you like this video, hit the like button, and if you still have any query or I haven't included anything, then please comment below. I will hopefully answer all your queries, and subscribe to my channel for more videos, and I have included a link below. From there you can get this code. So thank you, have a nice day.